Okay, I think we're ready to start. Hannah and Jacopo, you're ready? Right. Okay, so hello everyone. I warmly welcome you to our next English session, which will be held by Hannah and Jacopo Pellegrino, who you can already see right below the presentation slides. Hannah is the and CEO of Right Based on Science, which is a Frankfurt-based climate startup that's developing science-based effectively manage climate strategies. Jacopo is the director of information management systems and works in the model development of Right Based on Science. Throughout the past years, they succeeded in developing a software allowing companies to calculate their contributions to man-made climate change. If you have any questions to Hannah and Jacopo during the speech, please just write them in the chat and I will collect all of them and receive your answers right after the presentation. Hannah and Jacopo, we are very happy to have you here as a part of our conference and are keen to learn more about your software, your backgrounds. So this is yours.
Thank you very much. Thanks a lot. It's really a pleasure to be with you in this digital conference. So yeah, dear everyone, Jacopo and I from Right Based on Science are very, very happy to introduce our work to you and to have the opportunity to, inspire you probably a little bit that technology is a quite important component of making this world a better place. And temperature alignment analysis, so the area in which we work, provides quite a huge potential for the transition to a well below 2-degree world, but also quite significant technical challenges. So why did we embark on this journey in the first place? The reason could not be better expressed than in the words of Larry Fink, who is the CEO of the largest asset manager worldwide called BlackRock. And in 2018, he said that within the next 5 years, all investors will measure a company's impact on the environment to determine its worth. So with our temperature alignment metric, X-degree compatibility, we're doing exactly that. We measure a company's impact on climate change, and we regard climate change as quite an important component of this term environment. And the results are expressed in a quite tangible degrees Celsius figure, which can be understood by everyone. And that makes our X-degree compatibility so powerful. So to illustrate the meaning of temperature alignment analysis a bit more to you, just picture two companies from the same sector, so two car companies, to keep it easy, two competitors. One of them is contributing to climate change levels of 0.3 degrees below the Paris Climate Agreement. That's the left company. And the other one on your right is contributing to climate change to levels of above 0.7 degrees of the Paris Climate Agreement. And now imagine you are a potential client of one of those customers. So you're looking for buying the product that they provide. Who would you choose as your partner for the future? And now imagine you would be a talent seeking an attractive employer. And again, who would you choose as your future employer? Who do you want to work with? So in general, what do you think? Who has more capital available, both human capital, but also financial capital, to tackle those quite challenging issues that will come in the transition to a well below 2-degree future? And who do you think will be assessed better on the stock markets and in the market in general? So that's what we believe is quite a good impression of why temperature alignment is so powerful. Our X-degree compatibility model is the engine behind, or is an engine that calculates such temperature alignment metrics. So in a nutshell, the XDC model is an economic climate impact model, which analyzes the degree of global warming by 2050 that an economic entity, such as a company, is compatible with under various scenarios. And the XDC model calculates those XDC values based on 3 different steps. First of all, we calculate, okay, how many emissions does a company actually need to create value in a given scenario from a base year to 2050. So what is the emission intensity of my company? And then in a second step, we quantify the amount of emissions that would reach the atmosphere if the entire world operated as emission intensively as the company under consideration. And then the third step is that we calculate what level of global warming would we expect by 2050 if that amount of emissions that is computed in step 2 reaches the atmosphere. And the result of this is then our X degree compatibility. And Right Based on Science is the team developing the model, maintaining it, improving it, and applying the XDC model to use cases in the real economy, but also in the financial economy. And Right was founded to really actively shape and engage in this transition to a well below 2 degree world. I don't know if some of you know this feeling of helplessness when you think about those challenges that are inherent to a future shaped by global warming. Well, I did back in 2016 when I founded Right Based on Science together with my partner. And I decided to do something against this helplessness, to get active. And today, we're 30 experts from 12 different nations, and we take a lot of pride in working on this quite meaningful component of the transition to a well below 2 degree world. And at the beginning of this presentation, I told you that the potential of temperature alignment analysis goes hand in hand with a significant amount of technological challenges. And here are some of them, and Jacopo will later on go into them in detail. So the first technological challenge that we have refers to scalability. As our stakeholders from the financial world, like investors and banks, they ask us, okay, how can we use the XDC model for computing XDCs for a large financial portfolio containing more than 10,000 titles? How can this be possible? The second issue, or the second challenge, refers to modularity, as our stakeholders from the real economy ask us, how can we calculate the XDC of a solar park, for example, to understand what panels we should choose for it to be Paris aligned? And then our broader stakeholder base is very, very interested in transparency. Transparency is a key requirement for our stakeholders, because they ask us, how can we make sure we really understand what the XDC model does so that we can confirm the regulator that we know what we do in terms of climate-related risk management? Now I hand over to Jacopo.
So when it comes to climate science, I know that some of you may have the feeling that, we talk about climate problems, climate risks, but it's no more than sitting around the table and having very long and maybe boring discussions. I know this is somehow a shared feeling, and let me tell you that, to be honest, there is nothing can be further from truth than this. When I moved here in Germany, I started working for a space company. And I was really excited for having the chance to tackle very interesting challenges, work in a cool environment, learning cutting-edge technologies. Because, my expectations were very high since we were sending satellites into space. But after 2 years, then I decided to leave because due to many reasons that I don't want to mention here, it was very difficult and very hard to propose new ideas and have modern technologies involved. This is just to tell you how sometimes our preconceptions can be incorrect. And this is really the case, because here at RISE, we try to take advantage as much as possible of technology and modern approaches to solve complex and interesting problems. So here I found a place where I can provide new ideas, collaborate with highly skilled people, and getting interested in what I'm doing. So in the next slides, we will talk about how we strive for scalability, for modularity and transparency, which are our key focuses. Let's start with scalability. So in principle, as Anna said, the process of calculating the XDC is relatively simple. We get input from our customers. We have our model implemented in Python in our local machines. And out of that, starting from emissions, we can get as output an XDC value, a temperature value. This process is clearly straightforward, but let's suppose we need to answer the question above. So how can we use this model to calculate XDC for over 10,000 titles in our portfolio? Of course, the process is fine, it's simple, but it's not scalable enough. So how can we improve the situation? Starting from our XDC model in Python, clearly we don't want to reinvent the wheel in terms of technology. So we try to use as much as possible what's on the market, what's available for us, and what can increase our scalability. In our case, we start focusing on the infrastructure. We need an infrastructure that is capable of supporting our products with appropriate degree of scalability so that it can be accessible to multiple customers and can provide a calculation quickly enough. So starting from our XDC, we deploy into a GitLab repository, which of course we not only use for scalability, but also for code sharing and collaborative implementation. But thanks to the automation and to the CI/CD pipelines in GitLab, we are capable of deploying our testing and production code into Docker containers. As most of you might know already, Docker containers is a widely adopted technology that allows for a flexible and scalable environment, and especially a virtualized environment. The flexibility and scalability of this is one of the key points compared to other technologies like, for example, virtual machines. Our Docker containers are orchestrated by another piece of our infrastructure, which is the Kubernetes framework that we use for orchestration of the containers. And thanks to this, we can achieve the degree of scalability that we really need for our product to be effective. On top of that, we have an instance of a tool named Rancher that we use for administration of this Kubernetes framework. So we can already see here how a process that appears to be simple at the first glance actually hides a lot of steps and technologies behind the scenes for it to be performed effectively. The second key point we want to focus on is modularity or extensibility. Although a powerful infrastructure plays a key role in scalability, as we've seen before, it's not possible to forget about the importance of a robust implementation of the software being executed. So apart from a performance perspective, which in our case is given via scalability, via the infrastructure, our product needs to be extensible enough in order to accept new changes and meet customer demands. Let's suppose we want to answer the question above again. So how can we calculate an XDC for a solar park, or maybe for a municipality, or any other financial institution or entity that we currently don't support? This is a really realistic and common situation, and being late or even worse, failing to meet these goals can be a serious issue for us. So in order to allow for this flexibility, we have an extensible solution, and it's extremely important for us to maintain our product modular. How we do that? So let's have a look at our structure. Also in this case, we try to rely as much as possible on different technologies in order to maximize our efficiency. In particular, we start designing our product using a UML approach. So we define our class diagrams in a nice and visual way so that we can look at the architecture of our product before implementing it. And in this case, we can spot critical structures or maybe bottlenecks that can affect the interaction between components, so that we solve them and address them before actually spending time on implementing the code. On top of this, we also take the advantage of having this structure automatically converted into Python classes, in our case, that we can then fill with our business logic. What about this business logic then? Our modular idea can be depicted by this picture on the right. So we try to design our product as made up of puzzle pieces that can interact with each other. In particular, we have the core logic of the model in these core modules that again contains the business logic of our model that we want to expose to other tools. These tools could be local tools that interact through a local API, or web tools that can interact through a REST web API. Thanks to this design, it's possible and does not require too much effort to integrate new components that again could be local or web-based products that we want to interact with. On top of that, we are also capable of exposing this REST API to external customers that might want to integrate their product and ours. Clearly, different people are working on this product, And our team needs to interact a lot, and sometimes it's also important to have pair programming sessions, for example. And again, technology here helped us again a lot, especially in the last months, since it was not possible to work together in the same office, for example. So thanks to our development tools, like for example Visual Studio Code, we were able to start a shared coding session and work together as we were in the same office, even if we were hundreds of kilometers apart. The last key point is transparency. And again, here, our culture of working together is not only limited to the coding part, which of course is important, but it's not the only one. Due to the topics that we address, multiple subjects need to be involved. That's because our topic is complicated by nature and requires a lot of knowledge, requires a heterogeneous and interdisciplinary team to tackle these challenges. We also like to interact as much as possible with university in order to be exposed to fresh ideas and new technologies. But this also means having to deal with a lot of literature, documentation, and code, either design or actual implementation of code. All this in order to get our XDC model done. The problem here is that these tons of documentation we have to manage can lead to a very difficult situation and maybe an intricate situation like the one we can represent here with this image on the right. This is clearly not desirable for transparency because it can affect the way we communicate our model to the external world. In order to be credible and meet our goals, our model needs to be reliable as much as possible and have clear and solid scientific foundations. For that reason, we make communication, integration, and efficiency our priorities. Now, let's see how we achieve this. In order to enable an effective communication and exchange of information between the teams and the team members, we make a heavy use of Jira, which is a widely adopted tool for project management across a lot of companies. Normally, we try to use Jira as much as possible in an automated fashion so that we can boost efficiency. And all the projects and tasks that we manage through Jira normally have a counterpart in GitLab, which we already mentioned. And again, we not only use GitLab as a repository, but also as an integration tool between our local machines and our production environment. Since we want to keep this integration working smooth, we need to make sure that all the components we work on are understandable and clearly documented. For our XDC model, for example, we use a tool named Sphinx, which allows us to convert documentation from within the Python code directly into a more readable and user-friendly format. For example, an HTML page, or even better, a conference page. Again, we use Conference a lot for documentation and also for deploying our code documentation with a single click. This is an example on how we can use these tools and this technology to boost our efficiency and to save as much time as we can to focus on the things we really need to focus on. So we can see how, thanks to a lot of tools, so we can turn the situation from a very intricate, like we have now, to something more clear and straightforward. In conclusion, we can go back to the initial question, how can technology serve the world? So ultimately for us, it's not like technology itself is going to serve the world, but rather people with their ideas, their skills, and their preferred servants will do. And in doing this, they will find in technology a great supporter to take advantage of. Our mission for this is to increase transparency on climate-related risks and opportunities and make people aware of them. The strong use of technology that we presented in these slides was our answer to the question, can technology save the world? Now the question is, what is your answer? Thank you.
Thank you very much.
Thank you very much for the into this current and topic that hopefully growing more in importance throughout years. Well, we received quite a few questions in the presentation, some in the session chat and others that also reached me via message. And of course, it would be great to receive some answers to them. So the question that reached us is announced to Hannah. Hannah, was the idea to found Right Based on Science born? Like, have you always been interested in topics related to climate change?
Yep. So I've been working since 8 years now on science-based climate metrics. And back at university, I had a course where we looked at documentaries about capitalism, and one of them was about the carbon bubble. So that 75% of already priced in fossil fuels are not burnable in a well below 2-degree world. And that is that's really an exciting number. So I worked on this number more and more, and I tried to understand, okay, if 75% of fossil fuels that are priced in the market already cannot be burned, that means that a lot of companies are actually over-evaluated on the stock markets. So how can we make this visible? And through my previous employers and also a lot of research that I did on my own, I came to this point where I said, okay, I really want to work on this the whole day. So I founded this company together with the co-founder, Sebastian, and we did not have a product. We just had this carbon bubble thing and a lot of literature and a lot of hypotheses. And then we did quite a bit of research and like exploring the topic. And then all of a sudden it came, okay, I need to understand how much degrees compatible I am under various business development scenarios. And then we started building the XDC model. That's the history of the idea and why we founded this company.
Thank you very much for sharing this with us. The next question is more related to the industries that make use of your software. So are there any industries that are specifically interested into it? And have you realized a current trend? So is interest growing recently? And do you realize any changes in interest related to the Corona situation throughout the last months?
Yeah. So interest has definitely been rising over the last couple of months. Back in 2016, nobody understood what we do. Then in 2018, we had this quite interesting citation from Larry Fink, and today, like the biggest and largest asset managers worldwide and politicians are speaking about temperature alignment. Not because of us, there are also other providers, but we were really the first ones like exploring that idea further. And in the last couple of months, interest has really been rising due to this global acknowledgement of the meaning of temperature alignment and the powerful component that it can be of the transition. And single industries that are particularly interested is the food sector, actually. So vegan products, this industry is already affected by climate change. Like, can we replace meat? What does it mean for our temperature alignment? So we really see a lot of food production companies now approaching us to understand their temperature alignment. And the rest is totally mixed. Of course, the financial industry, very, very interested into this topic because they are pushed by the regulator to better understand if they are invested in companies and assets that are probably not so valuable anymore in the future as they are today. Of course, also the energy sector, highly interested in that topic. Yeah. And due to Corona, we just saw over the summer, it was, companies and potential clients, they had to get used to the situation. But then afterwards, and we really spoke a lot with our clients about this, they said, okay, now climate is actually the topic that we need to address in order to position ourselves in this difficult time. If we mess up on the climate side, then we won't get access to capital and talents and everything we need to manage those very, very difficult times ahead of us. So climate plays now quite a strategic role in tackling and getting over this Corona situation.
Say that it's a good mixture of companies that want to do it right from the beginning and established companies that realize that they have to change now?
Yeah, so it's both. It's companies who are really realizing to change now, and then also, for example, a lot of young portfolio management companies. So a lot of young asset managers developing new financial products, and they are also very interested in that innovative way of designing financial portfolios to be Paris aligned, because that is now a very good sales argument for them to collect money and invest that money into those Paris aligned companies. Yeah, so it's both young and also established companies.
Good to hear that. Another question that somehow relates to different types of companies, but more related to the fact of how the model integrates them. So does the software take the different industries into account when it comes to comparability? So you can really compare companies from different industries, or you can just compare tech companies with the metrics. How does that work?
Yeah, so we can compare sectors against each other because we also calculate an XDC for a sector. So we do the same process of calculation, starting with the economic emission intensity, but not with the company, but with the sector. So we're aggregating all the companies that we have for the sector, and then we treat them as a super company, and then we calculate the XDC of that entity, and that can then be compared to the XDC of a single company, so that we don't compare a telecommunication company to an energy company. That's very important, of course, for interpreting the results.
Thanks for clarifying that. Another question was, what is the key of your algorithm with regard to softwares that are on? So what differentiates your software from your competitors, and what is your key point of sale?
So two things here. First of all, we are working with an economic emission intensity. So the economic side and the economic component plays quite a key role in the XDC. So the XDC's logic is based on this acknowledgement also of the EU that emissions need to be decoupled from gross value added. So we need to decouple emissions from value creation. Emission-intensive economic activity needs to be replaced by low emission-intensive economic activity, because we need to keep this economic system stable, but with a significant reduction of emissions. And that logic is, so we're the only one following that logic in defining what a low and a high temperature is. So a low temperature we have for a company who is really decoupling emissions from its value creation, and a high XDC, a high temperature we have for a company who just refuses to decouple emissions from its value creation. Yeah, that's one of the USBs, and the other one is that we have this climate model connected to the XDC model. So other providers, they calculate a score, which is a very simplified version of a temperature alignment, and we really calculate a real temperature because we're using a climate model for the third step. Yeah, that's also our USB. And another USB is definitely this technical, the way we tackle this temperature alignment topic from a technical perspective. So we can provide scalability, we can provide transparency, and we can provide modularity. This is also something which is absolutely not common in our space.
Thank you very much for this information. Could you also give us a rough idea about how expensive it is for a company to calculate its impact on global warming based on your software? So what are also the main factors driving the prices?
So the main factor driving the price is the size of the company. So for small and medium-sized companies, a status quo analysis, which is a report, costs €5,500. And then the software with which we can calculate the XDC under different scenarios, so we can change assumptions, we can do really deep dives into the figures. It's around €8,000 for small and medium-sized enterprises on a yearly basis. And for large companies, this is just a little bit more expensive. So the status quo report is €7,500. And the software, so a yearly license, is around €10,000.
Okay, thank you very much. I just received another question, which seems quite interesting to me. So given that the results of the software are not satisfying for a company because they just expected to receive a better result, have you ever experienced that the company questions the validity of your model?
Yes, absolutely. That's usually the first reaction. So I have given my best in terms of sustainability, and this is why your model must be wrong. So I think that was one of the funniest reactions I ever got. So I have really tried my best here in the sustainability department. So the only explanation I have for this is that your model is wrong. Yes, we received this reaction a lot, which is just human. Yeah, so I get this very uncomfortable information, and I just want to refuse it. I want to find excuses for it. I want to find easy solutions for this horrible feeling. Yeah, that happens quite a lot, but then we really benefit from the transparency, from the scientific foundation, from this very objective XDC figure to explain them why this is the case, and then also to show them, hey, if you have a climate strategy and if you reduce your emissions, if you switch to renewable energy, then this number changes. So it makes sense to set up a climate strategy which is steered and monitored with the XDC, and then and then you really reach the people, and then you come into a working mode. So that is only an initial situation, and luckily we're already a bit experienced in that, so we keep a cool head.
Perfect. There was another question related to the model calculations. It is, how do you handle the inclusion of structural imbalances? Like a company based in Germany may have, for example, more financial resources available than a company that is based in emerging or less developed countries. So they have just different opportunities to follow sustainable standards. Is this also included in the model somehow?
So right now we just calculate XDCs for companies in OECD region or world regions. In order to provide that kind of detail, we would need to work with like purchase power parity for assessing the GVA potential for different companies in different areas of this world. And this is actually one of the tasks that our economists are currently working on to make sure that we can provide that level of granularity. Good point. Yeah.
Okay, that also leads me to the next question somehow, speaking about your future plans. One of our participants was wondering what your future visions for Right Based on Science is. So do you have plans to make it even bigger, more public, to receive more awareness? And do you have any conclusions about which sectors are still behind in general, which need to be concluded and especially addressed throughout the next years?
Yeah. So first of all, the vision, of course, we want to, so before I hand over to you with the technical vision maybe, of course we want to grow, of course we want to be more known, of course we want to win strategic partners that make sure we actually set the standard for temperature alignment. So this is what we want to achieve. We want to be the standard methodology for temperature alignment so that everyone is using the XDC and we have comparable and transparent and scientifically robust metrics, and don't need to argue and discuss so much about the metric itself, but start working with them, actually reducing emissions, developing companies, and we want to provide the standard for this, and this only works if you grow, if you get more known, if you win strategic partners, if you grow the team, if you make sure that you really fulfill those key requirements. So that's from the business development perspective.
From a technical point of view, of course, transparency is also being able to cover multiple aspects of a problem. So we try to develop our products in a way that can be expanded and get new functionality so that we can provide an answer to different questions, like, for example, what's the impact of a single person or of a city or different economic entity that at the moment we don't cover. So for sure, we try to keep our products in sync with the business requirements so that we can satisfy our customers, but at the same time increase awareness about this problem and provide an answer to problems that at the moment we cannot answer.
And in terms of the sectors who are still lagging behind, I would say it's the most emission-intensive sectors, unfortunately. And that may be connected to the fact that they don't like those numbers. So especially the aviation industry, they have their back against the wall. Also the shipping industry, so they're trying, or in my impression, they are trying to to present measures and strategies that just don't go deep enough, but they want to show something which is still feasible to them. And then also the financial economy. So although they are a key driver for this transition, they are still lagging behind what could be possible already, in my opinion. And also something which I think is lagging behind is actually the creative industries. So brand designers, information and communication designers, advertising companies. So all of them have not yet really cracked the potential of temperature alignment for the narrative for a company to position itself in this world, which is now more and more shaped by climate change and people trying to somehow connect to this. So I think, yeah, even the design industry, branding, communication is lagging behind in their contribution to the whole thing.
Thank you very much. Can you also tell us about the biggest challenges that you faced when developing the software? Like, was it hard to identify the relevant factors, or was it more like on the model development side?
Well, concerning the development of the model, there are a lot of challenges, starting from example, from how to translate climate science rule into an application, so a software application. It seems like it's easy, but there are a lot of things to keep in mind behind that. Another issue would be related to the sectors, how we want to handle them, how we want to handle data we get as input, so that we can compare a realistic and meaningful sector to a single company. Data is also a major concern. How can we make sure that the data we use are reliable and are consistent through the different products and different comparisons? So there are really a lot of challenges. This is why it's important for us to rely as much as possible on the tools that we already have and technology that already exists. So we don't have to take care of them, but we have to take advantage of them in order to focus on these challenges which are specifically related to the topic we are addressing.
Thanks for sharing this with us. The last two questions do not really relate to the software itself, but more to the company, right, based on science and on the experiences of you two. So do you two have any recommendations to future founders that are interested in the field of tech and sustainability and interested in how to connect both aspects?
Yeah, of course. So I think, first of all, the diversity of the team, if you go into technology and climate, is key, because you need those tech-savvy people, you need the scientific people, but you also need to have people who understand the business side of all of this. Mm-hmm. So sometimes we have conversations between the tech team and the business team, and it's really hard to make sure we speak about the same thing, and that the business side does not think that the tech team is already understanding everything that they say, and vice versa. So, like, making sure from the beginning that you are covering the most important components of climate change or any other topic that you want to tackle. So from the technical perspective to the scientific perspective to the business and socioeconomic perspective, I think that's really key. Otherwise, you can't make a business case. Otherwise, you can't develop the technology you need. Otherwise, you don't get access to the market. You need the whole package, and that should be considered when you start your team. That's from my side.
Yeah, from my side, I would say, since this is a really up-to-date topic and it's a new topic, it's important to experiment, to try things out. Maybe we try out a technology, realize this is not the best, we can switch to another one, but we also need to do some research on our side, experiment, and keep in mind that the cost of doing something wrong is always less than the cost of doing nothing, especially in this. So it's important to try and learn from mistakes and go.
Perfect. So it's about the good combination of hard and soft skills and motivation. Thank you very much. I think we answered all questions that arrived here in the chat. And as we also almost reached our time limit, I want to use the last seconds to say again, thank you so much for sharing all of these insights and also your knowledge with us. We wish you and your team all the best, and we are really proud that a startup like Right Based on Science is part of our conference today. So thank you, Hannah and Jacopo, for being here and sharing everything with us.
Thank you very much for having us.
Thank you.
Thanks
You're
a lot.
very welcome.
Have a nice rest of the conference.
Thank you. So goodbye, everyone, and have a nice afternoon.